Hello students, welcome back to the lecture series of fluid mechanics. We are learning the unit number 2, fluid statics. In first lecture, we have discussed about hydrostatic forces on submerged bodies, that is vertical surface and horizontal surfaces. Now in today's lecture, we are going to discuss about inclined surface. Myself Praveen Yadav, an assistant professor in mechanical engineering department. So the lecture objective of today's lecture also to know the total pressure and center of pressure in inclinedly immersed body, to know hydrostatic forces in submerged bodies for inclined surfaces. After end of this lecture, you will be able to explain the total pressure concept and center of pressure concept. Also, you will be able to explain about hydrostatic forces on submerged bodies or inclined surfaces. Now, consider an inclined surface immersed in a liquid. Now, this is the liquid container in which in inclined position we are inserting a surface. Let A be the area of surface, x bar be the depth of center of gravity of immersed surface from the pre-liquid surface, theta be the angle at which immersed surface is inclined with the liquid surface, W be the specific weight of liquid, h bar be the depth of center of pressure. Now here the inclination angle theta can be calculated in terms of sin theta, can be explained as x bar divided by, instead of L I can say L bar because I have used notation L many times. So L is nothing but the length up to the point x bar, inclined length up to the point s bar. Therefore L can be given as x bar divided by sin theta. L can be given as x bar divided by sin theta. Now looking towards the figure, initially we will calculate the total pressure. Now to calculate the total pressure, again consider a strip of thickness dx at any distance L having width b from point having width of b. Now here this is the thickness dx we have selected approximately at the distance of L with width b. Now since we have considered a strip of very small thickness, the pressure P acting at that point can be calculated as rho into G into H. But we know that rho into G is nothing but the specific weight of liquid and which is known as a W. So P can be given as P is equals to W into H. Now H is nothing but the vertical height. Suppose we assume that this vertical height is nothing but this distance and it is equals to x. It is equals to x, and therefore we can write a total pressure P is equals to W into x. Instead of H we have put out x. Okay. Now we know that pressure is equals to pressure force divided by area. Pressure can be given as pressure force divided by area. Now area of strip can be given as, area of strip is equals to width into depth. So it is nothing but B into dx. So total pressure on the strip can be calculated as intensity of pressure into area. So we can say that total pressure acting on the strip is equals to intensity of pressure P into area B into dx. But now here we know that P is nothing but W into x. So put out this value at here, we can write it as in total pressure of the strip is equals to W into x into B into dx. But as we know that L is equals to x bar divided by sin theta. X bar divided by sin theta. Similarly, x is equals to, x is nothing but this height. X is nothing, for this L purpose, we can write L is equals to x into sin theta. X into sin theta. So L can be written as x can be written as x is equals to L sin theta. From that formula we can put x is equals to L sin theta. So instead of changing the value of x, we can write this as W into L into sin theta into B into dx is nothing but total pressure on the strip, and therefore P can be written as W into sin theta L into B into dx. Okay. Now this equation of total pressure we have calculated only for this small strip. To generate generalized equation for the immersed body in the liquid, we can take integration of both sides. So total pressure on the body, integration of the strip is nothing but total pressure on the body P can be given as integration of W sin theta L B into dx. Now in this terminology, W is nothing but the specific weight of liquid and it is considered as a constant. Sin theta is the angle of inclination. Again, it is the constant, because at any position you can take the strip, theta will not be gets changed. Changes appears only with respect to the length, that is immersed length, and B is nothing but the width of strip. So, but we know that integration of L into B into dx is nothing but moment of surface area about OO. So we can write this as P is equals to W into sin theta, and this LB into dx is nothing but moment of surface area, and it can be given as A x bar divided by sin theta. So sin theta will get cancelled. So P can be given as P is equals to W into A into x bar. This formula is similar like to the previously we studied formulas for when plate is immersed vertically and when plate is immersed in horizontally. The intensity of total pressure P can be given as W into A into x bar. For these previous problems also we have found out, or previous conditions also we have found out same formula for total pressure purpose. Okay. Now we move forward for the calculation of center of pressure, that is H bar. Now again consider the same figure. Let C be the center of pressure of the inclined surface, which we already discussed. Then let the location of C is at the distance of H bar, which is known as the center of pressure distance. The H bar is nothing but depth of center of pressure below the pre-liquid surface. Let Ig be the moment of inertia of the immersed surface about point OO. Then X bar be the depth of center of gravity of the surface from the pre-liquid surface. Theta be the angle at which immersed surface is inclined with the liquid surface, and A be the area of surface. Now this is the condition, that initial condition we have discussed at first initial point only. We know that for a small strip B, we have considered a small strip at a here with width B and depth dx at the distance L. Then we know that the pressure acting at here is nothing but rho into G into H, which is known as considered for the small strip. Now we know that rho into G into W into X, so pressure P can be given as W into X. Now again we know that how to calculate the total pressure on the strip. So total pressure on the strip is nothing but intensity of pressure into area. So we have know that intensity of pressure is nothing but P and area is nothing but B into dx, width into depth. So total pressure can be calculated as by putting the value of P as W into X into B into dx, and which is given as w into L into sin theta into dx. Now how this L into sin theta comes, that written as once again at here, that how we have calculated w into L into sin theta into bx, because we know that L is nothing but x bar divided by sin theta is equals to x divided by sin theta, and it is similarly equals to h bar divided by sin theta, h bar divided by sin theta. Now the pressure force P x, now P is equals to pressure force into area. Now consider the strip of thickness dx with B and distance L from OO. Then pressure on the strip is equals to intensity of pressure into area. So it can be written as intensity of pressure we already calculated. It is equals to WL sin theta into B into dx. Now moment of pressure about the point OO, it can be given as W into L sin theta into B dx into L. So multiplying with L inside, we can write this as WL square sin theta into B into dx. Now this is nothing but moment of pressure about point OO for the strip of thickness dx. Now we wanted to know about the moment of pressure about the point OO for the whole body. So it can be given as capital M is nothing but integration of above terminology, WL square sin theta into B into dx. As we previously discussed, W is nothing but the specific weight, theta is nothing but the angle of inclination, and both are constant. So we have taken out as W into sin theta outside and integration of L square B into dx. But L square B into dx is nothing but moment of inertia of the surface about the point O. So we can write this as M is equals to W sin theta into I naught. W sin theta into I naught, where I naught is nothing but moment of inertia of the surface about the point OO. Okay. Now again in next, the sum of moment of all such pressures about point O is also equals to P into h bar divided by sin theta. See, the sum of moment of all such forces about the point O is also equals to P into h bar sin theta, where P is nothing but the total pressure on the surface. So this is called as an equation number 2. So equating equation number 1 and 2, we can know that P into h bar sin theta is equals to W into sin theta into I naught. W into sin theta into I naught. Now here sin theta gets multiplied when he goes at other side. When P goes at other side, it will becomes to the denominator. It will becomes to the denominator. So putting the values of I naught, we can write this as h bar is equals to I naught sin square theta divided by ax bar. Why below ax bar only comes? Because P is nothing but W ax bar. W gets cancelled, remaining is only ax bar. Now we know that according to the parallel axis theorem, I naught is nothing but Ig into h square. Now here instead of h, we have to put out the value of L. So our equation can be written as h bar is equals to sin square theta into ax bar into Ig plus Al square. Ig plus Al square. Now here consider with respect to theta, we already written that sin theta is equals to x bar by L, or L is equals to x bar by sin theta. So we are changing the value of L with the help of x bar. The above equation can be written as h bar is equals to sin square theta into ax bar into Ig plus A into, instead of L, x bar divided by sin theta bracket square. Okay. Now multiplying with sin square theta into ax inside, the first term will be Ig into sin square theta plus divided by ax bar as it is, plus when we multiply inside sin square theta will get cancelled, a will get cancelled, 1 x square divided by x will be remaining, and that is written as x bar, and therefore center of pressure H can be given as H is equals to Ig sin square theta divided by ax bar plus x bar. Ig sin square theta ax bar divided by plus x bar. So this is the methodology to calculate center of pressure and total pressure in inclined surfaces. The value of total pressure is same, only the formula for calculating center of pressure is different for every section purpose. Okay. Now we'll consider some problems for study at here. So problem is, consider a 1 meter wide and 1.5 meter deep rectangular plane surface lies in a water in such a way that its plane makes an angle of 30 degree with the free water surface. Then determine the total pressure and position of center of pressure when the upper edge is 0.75 meter below the free water surface. 0.75 meter below the free water surface. Now consider this is the plane where the angle of inclination theta is given as 30 degree. Angle of inclination theta is given as 30 degree. Its length is 1 meter. Its depth is 1 meter and width is 1.5 meter, and which is immersed in a water. Then its upper edge is 0.75 meter below the free water surface, which is given at here. Now consider x bar be the distance up to where we are considering the center of gravity. H bar is nothing but center of pressure. H bar is nothing but center of pressure. Now we know that total pressure can be given as P is equals to W into A into X bar. Now since plate is immersed in a water, we know that W is nothing but 9.81 kilonewton per meter cube. So, and area of plate A is nothing but 1.5 meter by 1 meter. So it is nothing but 1.5 meter square. Now to calculate the value of x bar, we can develop a generalized equation. So x bar can be calculated as x bar is equals to LU plus UM. LU plus UM. Now we know that sine of 30 is equals to U into M divided by M into N. U into M divided by M into N. So we can write this as x bar is equals to 0.75 plus M into Mn sin 30. Mn sin 30. I can say that x bar is equal to, x bar is nothing but LU plus UM. So it is 0.75 plus Mn sin of 30. Now sin 30 is nothing but UM divided by Mn. UM divided by Mn. So we can write this as 0.75 plus 1.5 by 2, that is nothing but width divided by 2 since it is the center, into sine of 30, and sine of 30 is nothing but 0.5. So it becomes x bar is equals to 1.125 meter. So we can calculate as P is equals to W into A into x bar. So it is nothing but 9.81 into 1.5 into 1.125 meter. So total pressure P can be given as 16.55 kilonewton. Now height of center of pressure using the relation h bar is equals to ig sin square theta divided by ax bar plus x bar, we know that area is nothing but 1.5 meter square. Ig is nothing but b into d cube divided by 12. So it is nothing but 1 into 1.5 cube divided by 12. So it is nothing but 0.281 meters raised to 4. So x bar can be given as, and x bar is nothing but 1.125. So h bar can be given as 1.166 meter. Now this is the circular plate. A circular plate of 1.5 meter diameter is submerged in a water with its greatest and least depth below the surface being 2 meter and 0.75 meter respectively. Then determine the total pressure on one face of the plate and the position of center of pressure. Total pressure on one face of the plate and the position of center of pressure. Now again, we know that diameter of plate is 1.5 meter, so area is nothing but pi by 4 d square, and it is nothing but 1.767 meter square. Now we know that P is equals to W into A into X bar. So referring to the figure, we know that distance SN is nothing but 0.75 meter. UM is nothing but 2 meter. So distance of center of gravity from the free surface, it can be calculated as Sn plus Gn, Sn plus Gn sin theta. That is nothing but that middle distance. So it is nothing but 0.75 plus 0.75 sin theta. Now here I think theta angle has been not given, but we have the two lengths, that is here the distance is 0.75 and here the distance is 2 meter, and this distance is 1.5 meter. This distance is 1.5 meter. So by this we can calculate the distance Lm. And we know that sin theta is equals to Lm divided by Mn. So Lm is nothing but Um divided by Ul divided by Mn. So it is nothing but 2 minus 0.75 divided by 1.5. So sin theta is equals to 0.8333. That value we are going to use that here. So x bar can be given as 0.75 into plus 0.75 into 0.833. So x bar can be given as 1.375 meter. X bar can be given as 1.375 meter. This is the only important step, that how to calculate the x bar at here. Once you know the value of x bar, again the total pressure P can be given as W into A into x bar. Since the plate is submerged in a water, what is the value of W? W is equals to 9.8. So putting these values at here, we can get 9.81 into 1.767 into 1.375. So it is nothing but 23.83 kilometer. Now again for center of pressure H bar, we know that H bar is equals to Ig sin square theta divided by Ax square plus x square. Again it is nothing but, what is the value of Ig? Ig is nothing but pi by 64 d raised to 4. So it is nothing but pi by 64 into 1.5 raised to 4 into sin square theta is nothing but 0.833 bracket square divided by 1.767. What is the value of A into x plus x? So putting these values, h can be given as 1.4 meter. This is what one more problem. An annular plate of 2 meter external diameter and 1 meter internal diameter with its greatest and least depth below the surface being 1.5 meter and 0.75 meter respectively. Calculate magnitude, direction and location of the force acting upon one side of the plate due to water pressure. Again, similar like to this, initially calculate the area of plate. Area of plate can be given as pi by 4 d o square minus di square. So it is nothing but 2.356 meter square. Now depth of centroid x bar can be again calculated as 1.5 plus 0.75 divided by 2. So it is nothing but 1.125 meter. Total pressure of the total pressure force P can be given as W into A into x bar, that is nothing but 26 kilonewton. This force acts perpendicular to the plate, so it is acting in a direction which is 90 degree minus 22 degree, that is 68 degree. Now center of pressure H bar is given as Ig sin square theta divided by Ax bar plus x bar. So again Ig is nothing but pi by 64 d raised to 4. So here again do raised to 4 minus di raised to 4 into sin square divided by pi by 4. X bar is nothing but area is nothing but pi by 4, 2 square minus 1 square into x bar is nothing but 1.125 plus 1.125. So it is nothing but 1.164 meter. Similar kind of problem for a triangular plate. A triangular plate of 1 meter base and 1.5 meter altitude is immersed in the water as shown in figure. The plane of the plate is inclined at 30 degree with free water surface and the base is parallel to and at a depth of 2 meter from the water surface. Find the total pressure on the center of pressure. Again, area of triangle is nothing but 1/2 B into H. So it is nothing but 0.75 meter square. Angle of inclination theta is equals to 30 degree. Again, at one point, at the initial depth of immersion is 2 meter from the water surface. So x bar can be requires to be calculated as by considering this is a triangle. So 2 meter distance is initially plus side of this triangle. So side of this triangle is calculated as considering by this angle as a 30 degree. Not considering this angle of 30 degrees has been given. So sin 30 is equals to side divided by 1.5 by 3 because we are putting the center of gravity towards the base, and towards the base it is nothing but h by 3. So it is nothing but 1.5 by 3. So side can be given as 0.25. So sorry, by mistake I have written here the 0.5. It is 0.25. So x bar can be given as x bar is equals to 2 plus side, and it is nothing but 2 plus 0.25. It is nothing but 2.25 meter. So P can be given as G, that is water 9.81. A is nothing but 0.75 into x bar is nothing but 2.25. So it is equals to 16.55 kilonewton. Okay. Now center of pressure H bar can be given as Ig sin square theta divided by Ax bar plus x bar. Again, Ig is nothing but B H cube divided by 36. So it is nothing but 0.09375 meter raised to 4. And sin theta is nothing but 1.5 minus 0.75 divided by 2. How it comes? So this is actually this 1.25. So it can be given as sin theta is equals to 0.375. So theta is equals to sin inverse of 0.375 into 22. So it is nothing but 0.09375 sin square of 22 divided by 0.75 into 2.25 plus 2.25. So it is nothing but 2.264 meters. Okay. So here we add when the body is inclined with respect to the normal surface of water. In next lecture we are going to discuss about the curved surface, and then we have completed this all 4 types. So meet you in next lecture. Thank you.